Hello everyone and welcome to Handmade Hero. This is the show where we code a complete game live on stream on Twitch. We don't use any engines or libraries. We are actually in the process of creating an entire game from scratch so that you can see the entire development process and know absolutely every last piece of code that goes into making a game run from the engine up to the gameplay and everything in between. Now, right now, we're in the middle of finishing up a change to the way that we're doing assets. We had some preliminary stuff in there that would just load assets off of disk from BMP and WAV files. But now we've kind of made things a lot more consolidated, and we have a way of building our own asset pack files, which can be easily transmitted, stored, sent, traded, anything else that you might want to do with them. And those asset files contain all of the data necessary to run the game. And in fact, you could have multiple asset files and it would merge the assets together and stuff like this. And the asset file itself contains all the bitmap data, all the wave data, all of the metadata that's required to know what those things are, and all sorts of other good stuff like that. So that is what we have already done, actually. And really all we're doing now is converting it so that our asset streaming system runs on top of that instead of ever accessing the BMP and WAV files directly. We already did the port to it, but we loaded the whole file at once. So what we're doing now is we're just kind of cleaning up the platform API portion of things so that we can get that data asynchronously from the operating system and not have to load the whole file at startup. That's what we're doing. And that is what we are going to do today. So if you would like to follow along at home and you have pre-ordered the game on handmadehero.org, today is day 152, and so if you want to unpack day 151's source code into a directory, that is what we would be programming on today. So please go ahead and do that if you would like to follow along. If you would not like to follow along, then you just don't have to worry about that. All right, so here we go. Where did we leave things? Well, if you remember, we left things where we had almost finished porting everything over, but there were a couple last little things I wanted to do first. So what I wanted to do was get rid of this old sort of notion that we had to know what we were loading, because what I sort of pointed out was that the only reason we previously had to have two different paths for whether we were loading a bitmap or a WAV file out of in our previous asset system was because we actually got data from those files, like the dimensions of the bitmap or the number of samples from the WAV file. And so we had to have two different paths because we had to actually know what we were working with. Now that we've moved to the asset file, all of that metadata has been pulled out into an upper level that we've already loaded. So really, when we go to get data, we really don't have to do anything. We already know exactly what's going to be the layout of the data, and everything is perfectly set in place for us. So what we can do instead is just use a single piece of code that just loads bits off the drive, basically, and all we have to do is when we know we need the bitmap bits or we know we need the sound sample bits, just issue the same kind of asynchronous load, either case, to say, here's the range of bits, here's where I want you to put them in memory, and that's it, right? We don't actually need anything else from that system. So I already did that for the bitmap loading code, right? It's this stuff right here. And I already if-zeroed that out, so we're just running off of the sort of load asset, the standard load asset work stuff, right? So we already finished this. In fact, we can just get rid of this. I don't think we need it anymore for anything. So we already got rid of that, and we transitioned bitmaps to using this load asset work. But what we haven't done yet is we haven't gone and done the same thing for audio. So what I'd like to do is do the same thing for audio, get rid of this load sound work thing, right? Just get rid of that, and get rid of load sound work, the function as well, right? So that load sound will work precisely the same way that load bitmap works, where it sets up what it needs first, and then it just goes ahead and issues the load for the data and waits for that to arrive. Okay. So in load sound work, what were we doing? Well, we were setting up like the sample count and the channel count and these sorts of things. Again, I don't know that we need that. Oh, well, I guess we do, because we have that loaded sound. We have this thing. So we have to copy those out of the HHA asset into here. Now, I do wonder why we bother copying these things out. It kind of seems like maybe we could just use them directly most of the time, but maybe that's not true. We can cross that bridge when we come to it, certainly. It doesn't really hurt to copy anything out, so either way, not really a big deal. So anyway, what we need to do first is we need to take a look at that load bitmap function, I guess. and see all the stuff that it does, because we're going to want to do basically the same stuff that it does, right? We're going to want to do this. So in here, right, where we do this load sound work push, we're going to need this to turn into a load asset work push. And so what's the stuff that stays the same? Oops, that was a bit of a speedy jump there. Too fast for me. So when we push one of these load asset things on, the task is the same thing, right? Nothing changes there. The asset slots, it doesn't matter whether it's a sound or bitmap slot, the slot's still the same. The file handle, again, is 0 just because we haven't done that work yet of actually doing the file load stuff, so we're going to have to, that's like the platform loading stuff we're going to be focusing on after we finish this. The offset, again, no difference here. It's just going to be whatever the asset says its offset is. The memory size will compute in a second. Destination is going to be that's the sound sample data, right? So that's going to be the, we could even introduce a sound memory thing here if we wanted to. The final state is going to be asset loaded just like before. And then the slot that we actually have here, right? We're going to want to do that slot sound equals sound sort of a thing where we kind of say, all right, now point so that you're pointing to the correct thing. And we already fixed this stuff here when we did get bitmap. We already fixed get sound to check to see whether or not the asset state was loaded, and if it was, then go ahead and do it. Now, one thing that I should mention here, actually, I think this is probably something we should do now that I think about it, because we kind of cheesed this. This is a little cheesy, and so I want to go ahead and uncheese this just slightly, which is to say that really what we wanted to do was probably something more like this, because I did it with a ternary operator, which is obviously more expedient. But the problem with the ternary operator is really we need to put in a thing here, which is that we want to complete previous reads before future reads here, right? Because what could happen is the compiler could have moved this thing. The compiler could move this read up above this check, and then we would have an incorrect data situation, right? So we don't really want that to happen. We want to make sure it reads this thing first so that there's no possibility that this thing got read before it was completed, right? And again, don't know that I have to think about that for a second to determine whether I thought that was ever actually a possibility on an Intel chip. But remember, we won't necessarily only be working on Intel chips. If we do port this game eventually to something like Raspberry Pi or, you know, any kind of like an Android device or something like that, we're going to be probably looking at an ARM device, and ARM devices are potentially going to have something else, who knows, although I think they have strong memory ordening as well. So again, don't really know that we care about this, but I should write it that way just in case, because it doesn't incur any of a speed difference here, and this can just compile away to nothing if that turns out to be necessary, so that's fine. Now I'm going to go ahead and take a look and make sure that we actually have one of those, because I don't think we do at the moment. Yeah, so basically compute previous reads before future reads would be a read barrier here. I don't actually know what that would be on LLVM, so I feel like I'm going to put a to-do here and say not sure. I guess I can get rid of that. Yeah. To do other compilers. So yeah, I don't really know. This is a full memory barrier, and so I'm just going to go ahead and put that in here. But I'm going to say, you know, does LLVM have real read specific barriers yet? I don't know. So somebody who works on LLVM more often than I do, you know, could go ahead and tell us if they've added something that would allow us to specify, hey, this is a read barrier, not a write barrier, guys. Okay, so yeah, that's all I wanted to check there. I just wanted to make sure. I think that's a more reasonable thing to do, because remember, this is an inline function, so this code could get slotted into something and get rearranged all over the place, and we really want to make sure that the compiler isn't going to do anything speculative ever. I don't know that it really could, but since we're not checking the value of slot, I feel like it couldn't, because doing that access, what if this was sort of saying whether slot was valid? No, but it's accessing off a slot. I don't know. Like I said, kind of crazy, but I feel like it's safer to write things the real way that you intend them to be and put in the barriers when you actually think there's a barrier, because it really can't hurt in that case, right? All right, so back to our main event here. Let's go back to getting our load our load sound working. So what I want to do is I want to do essentially the exact same stuff here, where I'm going to pull out the info, and I'm going to pull out the sound stuff like so. And so that we come in here, all of this stuff will work properly. I'm going to get rid of all of this, right? But I'm going to go ahead and this push struct here, I'm going to keep that where I go ahead and say, all right, my loaded sound is going to be a new sound. I'm going to do a push struct onto the memory arena there for that. And that sound is going to be what we set up here. So I've got to initialize it to point to things that make some sense, right? And I also have to do like this computation here, right, where I compute the memory size that it's going to take, right? And then when I actually do this stuff here, again, I'm going to use the exact same thing. So now we're completely symmetric pretty much in how we're doing everything. I can get rid of that because that's the same. And that's really about it, I think, right? I don't know why. I'm not 100% certain why this is down here. Oh, I know why this is. This is basically, remove this as soon as we actually load things. This is our little, like, hey, right now we're just loading the whole file at startup to make sure things are working properly. So that's going to be the same thing here, where we're going to have to sort of make that work out right. So, okay. So let's put that, though. I kind of want to put that up here, I think, probably. And I'm going to kind of put that up here as well. Yeah, that looks a little bit better to me because of what we're going to do in a second. Okay. So I think most of that's good. We just have to start thinking about this sound now to get the sound stuff right. And here's the loaded sound thing. So some of it's pretty obvious what we would do, right? The sample count is just going to come out of that info structure. There's really nothing interesting that's going to happen there. The channel count is going to do the exact same thing. And then what we're going to do is we're going to loop over those channels, and we're going to make sure that those channels that the sample pointers point into the right location in memory for once we load it in. So the first thing we want to do, again, sorry, I just got to rearrange this here. The first thing we want to do is figure out how much memory we're actually going to need for everything, right? And so we're going to want that channel count. We're going to take the channel count. We're going to multiply it by the number of samples, because we know we have the same number of samples in each channel. And then we're going to multiply it by the size of a sample. That's the total memory we would need, right? Channels times samples times that N16, right? Times the size of the sample. Okay. And since we load on a line from this thing, I don't think there's actually even anything we need to do alignment-wise, although, if we were going to start doing fancy things with alignment, then we would start doing them here, right? So that's the memory size that we actually need, which means that the sound memory that we're going to want is going to be allocated here. So I'm going to want that push size there. I'm going to allocate the sound memory. Again, this is kind of just mirroring exactly what was happening in load bitmap, where we do the push size here to get it out of that assets arena, right? So we're just providing space for ourselves, right? And then what we're going to do is right after that, because we're not really going to use it, we're going to go ahead well, you know what I could do even? I could just copy. I could just straight up copy this as well, right? I could say, oh, okay, copy into sound memory, right? Whatever the contents were here. So I could actually make it exist in the right place in memory too by just copying it out of the asset file and into the sound memory location. Now, I don't remember if we ever actually made a copy function. I don't know that we ever actually did. We made a 0 function, right? But we never made a copy function, I don't think. So like memcopy, we don't actually have. I don't think. Anyway, I could be wrong. But I am not wrong. We just don't have one. So if we wanted a simple copy function, again, probably not something that we're going to use in practice very much. But if we want to have one, it's pretty straightforward, right? We just have to have something for a memory index that's going to be the size to copy, right? Then we need like a source and a dest, like so. And then we would just do something like the source. I would probably actually do it like this, maybe, where we just get a byte pointer to each one. There we go. And the reason that I say we probably wouldn't use this too much, or at least not in a lot of cases where we might care, the reason that I say that is because, you know, usually if you're going to copy stuff, I would have a little more knowledge of what it was we were copying, and we would know whether it was aligned or not. We would know whether it could be copied in like 128-byte chunks or not. I'm sorry, 128-bit chunks or not, to make it faster, you know, stuff like that. So, you know, this is kind of, you know, a really just sort of a throwaway copy. It's not something that we would ever call when we actually cared how fast something was being copied, if that makes sense. Because we in those situations, we would almost always have architected things to know that we could do a very fast job without having to do any checking. We could do a very fast job doing the copy properly, right? So yeah. So I'm just gonna go ahead and do the dumbest possible thing here. You know, there you go. That's memcopy, right? Not a whole lot to it. Oops. You're just going to take 2 pointers, advance them by the number that you wanted to copy, and put one into the other, right? So the majority of this function is just casting to a U8, if that makes sense, just so that we know we move by bytes. So yeah, we'll go ahead and do that, copy, and then we're going to loop through the channels, like so. All right, I'll take a look at the channel count. And for each channel index, we will have our sample pointer. So the samples for that channel are going to be equal to whatever the sound memory is currently at, right? So sound at, and I guess I could just do this in samples, like so. So whatever the sound is currently at, I could go ahead and make that be where we're pointing, and then after we use one, we just advance however big the channel size is. So we could say, like, you know, channel size equals sample count, right? Like that, and so we just advance by the channel size. Yeah? So that lines us all up properly for doing the load and all of that good stuff, and I think that's basically all we have to do. And so this can now be, you know, down here. All right, so we've got sound memory equals push size, all that stuff. We got to actually have the memory pointer. Now, we don't really need the memory pointer. In fact, I guess we shouldn't bother with that. I could just say void star memory equals push size, right? And then use it like that, because we really don't care. So it doesn't actually matter, because that we don't have to store what that actually was. It's only actually getting used here for copying and so on. And so that's going to do the loading, assuming that we didn't, you know, fudge it up. That all sounds good. Although I hear a little clickiness there. I don't love the clickiness. I feel like there's a little something janky going on there, and I'm not sure, right? I feel like there is a little clickiness. That's okay, because we probably should do some sound debugging. There was some other thing that someone was mentioning on the forums, by the way, that we probably should take a look at some point. So we might want to do some sound debugging there, but I just want to double check here. I want to see if there's anything specific that might be going on that I just recently introduced. Sample count. Let's see, sound at memory. That looks reasonably good. We store the sample count of the sound. Yeah, I don't know. I don't know that it's likely to necessarily be there. Yeah, so that might be a mixer side thing, but I don't know. We'll check that stuff out when we kind of go check out a couple things in the sound mixer at some point. All right. So I think that's all we really need to do there. I think load sound work is not really necessary at this point. We can kind of go ahead and get rid of it. It looks like, yeah, this was doing the exact same thing stuff here, so there wasn't really anything else that happens in there. So that all looks good. Yeah, so that all looks good. So now we've simplified things down quite a bit, actually, right? Because now we only have that one load asset work thing, and we also, all of this stuff is now not necessary. Right? This is just all not used. So really what we're looking at here, just to underscore kind of how awesome this is in terms of architecting things well and getting a lot of bang for the buck, is what we've basically got now is a file that's 500 lines of code that does streaming of bitmap assets and sound assets in the background, including streaming music for 500 lines of code. And it matches tags, so you can have arbitrary descriptions from the game to the asset system, right? That's 500 lines of code. That's pretty darn great, considering the fact that some of those lines are also about to go away, because I'm about to simplify this a little bit further when we no longer have to do the old reading in memory thing. Oh, and hey, guess what? These guys are also gone too, right? Because those all moved to the asset prep. So there you go. 430 lines of code for the entire asset streaming system, background loading, streaming music. That's pretty darn awesome. I have a feeling that if you were to look in a commercial engine, it would not quite be so straightforward. Anyway, okay, so let's figure out what's going on here in terms of the best way to move this now to actually reading data directly from the platform, right? Because you can see we pretty much already wrote the code for it. We just have to go implement, what has to happen there on the Windows side of things. So if we were to take a look at this, what would happen is, we would, and you know what I could also do? I could do a copy here of the bitmap memory to get rid of the overwrite. So something like this, I would say that, and memory size. Also, this would let me check to make sure our copy was working properly, which I don't actually know that it is, right? If our bitmaps look screwed up. Yeah, so there's definitely a bug in the audio. I can hear the click. So we know there's a bug in the audio. We definitely have to, I'm going to put a little to do there as something we should do as soon as we're done with this stuff. It doesn't need to be attended to now, but we definitely should do it. Fix clicking bug at end of samples. It could have also been something we introduced in the asset processor, right? Because we don't know that we were actually clean to the asset processor. We haven't really tested hardly any of the stuff, right? We're just kind of putting it all in place and saying, okay, everything works right. And now maybe we had to go through and find the little lurking buggers. All right. So everything looks good here. We've got the copies in place and they can just be removed. So basically what would happen, in fact, I guess we could just do this now. So if we just go ahead and remove these guys, right, if they just go away, we'd be left in terror land where we're actually using the assets, but we don't have them. So they're just blank or whatever they're going to be, right? And so that's fine. But the game still runs just fine. So now what we need to do is figure out how to get this stuff to work, right? We need to get this stuff to work. And the way that we need to get this stuff to work is we need to be able to actually get these file handles, because you'll notice what happens if I do now, if I run it now, is we'll just crash because we don't actually have file handles, right? We've just got a 0 sitting in there for the file handle. So there's no, right, it's as soon as it tries to actually do anything with the file handle, it's never even going to get to the stub calls. In the file layer, it's just going to crash as soon as it tries to dereference that. So what we need to do is figure out a way to actually get the file handle here, to actually get that out, right? So in order to do that, what we need to be able to grab the asset and get the asset to have an index that says which file it came from, right? And so I think, like I said before, what I realized after we wrote this, and I was saying this as we saw it happen, is when we load the tag array is totally awesome because it just flat loads directly in and we can use the tags directly. So tags just load directly in and it's good. Assets, since they need to refer to tags, that doesn't really work. The assets have to be rebased. Their values have to be rebased so that they point to the correct place in the tag array, right? And that's what we were doing right here, right? You can see us adding that tag base in. And so what I think I'd like to do here is I'd like to say, okay, so what we saw was that HHA tags are correctly loaded, are correct to be loaded directly. But assets, that just didn't work, right? That was not, we tried it. Again, like all architecture things I say, we got to try, we got to see what's going on. We saw that really assets, they change contents as they move from the drive into memory. And so what we've got to do is we've got to make the asset structure, I think we want to pull it back from having it be its own thing. And we want to kind of make that be something that actually lives in the correct, in the correct sort of, lives in a different state. So what I don't know now, and you can understand my dilemma here because I don't really have a whole lot of information to go on. What I don't know is, does it make sense to make a new asset struct, or should it just be part of the asset slot, right? And I really don't know. Because it's hard to say, whether you want to actually have the asset slot bother to have, any more information. And do we ever actually access that info part, the stuff, the tags? I guess what I'm saying is the tags we're sort of asking for separately. So I kind of figure, like, I think I want to leave asset as a separate thing, because it seems like the times that we're using asset are not the same times that we're using asset slot. There's only some occasionally when they're used together, but a lot of times they're just not. Like when you're looking for an asset, you never look at the asset slot. You only look at the actual asset itself to see what the tags are. And so that whole walk is walking a bunch of assets. I don't need to pull in their slot and their pointers. We never need to look at that, right? So I feel like I'm going to do it this way, right? And then, I'm going to have the first tag index here, and I'm going to have the one past last tag index, and that's fine. And then what I'm also going to have is I'm going to have the file index, right? So what file did it come from? So that way when we need to load it, we actually know which file we're going to load it out of, right? And that seems like something that's that we would want to know. Okay. So we also need to know its data offset, right? And then we've got some kind of a little straggler here. We've got some kind of we've got 32, we've got a 64 and then a 64 and then a 64. We need like something else here. I don't know what this is. Pad. Reserved. I don't know that there's anything else we need to actually store there. But that's what's going to happen. So anyway, here we go. We're going to grab those assets out. We're going to copy out the data that we need. So there's data offset, right? And I should probably put file index up there. So there's the data offset, there's the file index. And we know the file index because we're looping over the file, so we've got that, right? We know exactly which file it came from. We know the data offset because that's from the HHA asset that we are, basically pulling the data off the drive from. Like so. Yeah, and really, wait a minute. Right, so we actually didn't have this guy yet because it was the same dude, right? It was the same dude. So what we need to do is this. We need to first make that, get that HHA asset, which is the HHA asset array, plus the asset index, yeah, for this array. So this is it has a little bit more funk to it, right? There's a little bit more funk there. So basically it looks like this, right? I believe. So we're gonna iterate from 0 to the number that are for this particular asset type, right? And the index for that, in fact, I think probably we could get rid of all of this notion entirely here and just say it's like that, right? It's the asset count comes in like so. Yeah, that looks kind of better to me, right? Yeah. Assert asset count is less than assets asset count. This could be less than or equal to, though, I feel like. Then that would still be valid. So I'm not sure what was going on there. Why would this always be less than? Does that make sense? I don't understand that. Because wouldn't this be equal to asset count when we were done? And how is this assertion not firing you know what? So this was just wrong. It's because we hadn't run this path yet, right? That's the only reason that was working at all. Because we had not run this path yet. So yeah, I assert myself that this was just bogus and never would have worked. So really what we want to do is assert this, you know, up here, something like assert that the asset count at the moment is less than the asset count now, and then we increment it and say, okay, that's the one we're actually using, and then we get rid of this, right? So that way we're kind of stepping through the thing and going, okay, for each of these assets, we're going to fill it out, and we fill it out in here. And that pretty much gives us all the stuff that we actually wanted. File index, what is that? One pass last index, and then the pad, which we don't care about. So yeah, that's a little bit more what we want. And then what we need to do is we need to have the HHA asset array, which we would use just to load these things into a temporary place, right? We're just loading them as temporary information because we don't actually have, I'm not actually block loading them into the HHA asset array anymore because we don't have a giant HHA asset array. Yeah, so what we would do here is say, okay, we're going to read that data in, we're going to put it in the HHA asset array like so. And that HHA asset array is going to be something that we need to allocate as temporary memory, right? In fact, we only really need it for right here. So basically it could literally happen right here where we just do like a push of the temporary, and then we would do a pop down here. So we would do end temporary memory. So basically I just need something to hold these guys while we read them. So I'm just going to go ahead and actually create this HHA asset. It's kind of a mouthful. I should have picked things that are easier to say on stream, you know what I mean? But yeah, so I'm going to begin the temporary memory. I'm going to go ahead and get that array. And that's just going to be, you know, enough room to store these guys exactly, right? So I'm gonna go ahead and do that. And obviously I should probably just use the transient arena because that's exactly what it is for. So it would probably be, you know, tran arena, right? Let's see here. Where's that at? HHA asset array. So there we go. And that's really all I would need to do, except for the fact that I don't remember how I wrote begin temporary memory in this one. I guess that's how we did it. Temp mem, like so. And that would do it. And temporary memory, temp mem. Yeah. Okay. So moving along, we need to kind of look at what other stuff was going on in here that might be necessary for the asset, right? So if I look at the file format, HHA asset, let's see what's actually in there that we might need. So we have the bitmap and the sound info, and we still need that information, right? So yeah, I feel like, I guess actually, so all of this stuff we still need, right? So I guess I could also do it this way to avoid having to bother like knowing all the stuff that was in there exactly. I could just say that the asset just has one of these, right? And then has the file index or something, right? So it's just an augmented guy or something like this, right? And that seems like something that's kind of back to the way that we had it before. That just basically allows us to add more stuff in there, right? If that makes sense. So let's take a look. So that would just be, again, going kind of back to what we were doing here, where we, you know, had a little bit of a, yeah, so I guess I would do like that. And then wherever it wants HHA asset, we just do asset HHA, like that, right? Only now, we can also get at our file index, which is sort of the information that's not the same as what's in the file, right? Oh, and I would have to actually access the handle. So I guess I would here go, how do I want to do that? I guess I would say, well, I guess I just get it directly always. So I just have to get file handle for something like that, right? Where I just get the file handle. There we go. And that would just allow me to check it. That's really all I was interested in. There we go. And now, hopefully you guys can see this. I mean, if you, I don't know, if this is, you know, if you haven't been watching every day, then this probably won't be something that you've necessarily noticed. But you can see I kind of went back and forth on one part of this architecture, right? Like, whether or not the HHA was embedded in an asset, or whether it was not, whether it was a separate one or not, right? Like, we did a couple different ways. We did it both ways with the tags. We did it both ways with the assets. And I've kind of settled on looking at the actual requirements for what had to happen. It became obvious, like, what the types actually were. Right? It became obvious that, like, okay, we actually process assets as we load them, but we don't process tags. And so that tells me the thing that it is that I actually needed to know, right, about how to do the architecture. And again, that's why, you know, that's why you do it this way. That's why architecture should be experimental, not design up front. Because design up front, you're never going to get all those things. Never, ever, ever going to get them. I've never seen any programmer, the very best programmers I've worked with, never even try to do that sort of stuff because they know it's simply not possible. And so you never ever want to, like, think that you're just going to think of all these things up front. You can just try a couple things and make sure that, you know, your coding style is fast and fluid. You can go through these experiments and then just don't, you know, calcify the code base until you know that you're happy with sort of the way things seem to be flowing through it, and then you're at a good place, right? So yeah. Okay. Moving on. Let's go ahead and finish this stuff up here. So that's HHA. That is also an HHA. What else we got here? The assets, right? That's going to be, well, this guy is going away, right? We don't have this anymore. In fact, we don't have any of this stuff anymore. That's all going away. Goodbye, HHA contents. And so now what we've got is we've just got this get file handle for. It's a kind of obvious function, right? Get file handle for is just taking whatever the file index is, and it's going to look up in our array of files, which is right here, right? So it's going to take that assets and a file index. And first, you know, I mean, we want to just assert the fact that you're not trying to access a completely bogus file handle. Right? So we'll assert that file index is less than assets file count, just to make sure. And then what we want to do is go assets, files, file index, that file handle. I think it's just handle, actually. That handle is the thing we actually wanted to return. Oops. So that's it, right? Nothing particularly fancy going on there, but that gets the file handle. Yeah. What did I, oh, it's game assets. Sorry, my bad. Yeah, so that, too many different asset assert sorts of things. That is basically that. I don't think I have much else I want to do with that. And so now if we assumed that when we actually loaded the files, we were actually going to get their file handles, I think we would be good to go. And so I think we can now start to work on this code in earnest and actually get it to be working. So yeah. Cannot convert one from memory to memory star. That's totally reasonable. Here we go. Data offset, right? These are part of the HHA now, like so. And now we don't really have to do anything particular here. We can just sort of do something like this, right? And then we can just rebase those tags. So now whatever we were going to have in the HHA, we copy over, and then we just rebase just the tag portion of it. And so I think that's just about all the things that we would actually need. Unfortunately, this code is, we have no idea if it's any good or not, right? We don't really know anything about this code. We don't know, we haven't ever run it. It could have tons of bugs in it. So we're pretty much going to have to do something a little bit nasty here, which is we're going to have to do this sort of doubly unsure, right? Because we've got this code, which we just kind of wrote as the usage code. We don't know if it's got its own bugs, right? Mistakes I made, typos, or just logic errors, whatever, right? We don't know if that works, but we also won't have any idea whether our platform file IO code works. And so when you're doing something like this, you have a couple of choices. One is you could choose to try to test one of them. And so in this case, what we could do is write test code to test our platform reading code. Another one is you could choose to try and test this outer code, but that would be particularly difficult, I think, right? So pretty much you'd test the file code. When you're sure it was working properly, then you'd move on to debugging this code. But what I'm probably going to do is just to, do the whole thing and debug them together. And the reason for that is because the file code is so simple that I don't think I'll have trouble verifying that it is working as we debug. And so what I'm doing is I'm making a judgment call. I'm making the judgment call that the time it would take me to write the test code to test the file I/O is longer than the amount of time it will take me to manually verify that it is working as part of the debugging process, right? And so a lot of people ask about test-driven development, and that I'm just trying to give you some background into how that works. If your default answer is always one or the other, then you may waste a lot of development time doing the wrong one of the two, right? And so you kind of have to make judgment calls about those sorts of things and determine what your priorities are and what your goals are for any particular step in development. And that is really what informs you as to whether you should write a test or not some kind of dogmatic thing of like you should always do tests or you always shouldn't do tests or something like this, right? Tests are a tool, and you always need to think of them that way. And they give you certain benefits, and they have certain drawbacks, and you need to just like make that trade-off. Just like everything else in programming, it's all about the trade-offs and knowing how to make them effectively and efficiently. All right, so let's go to the Handmade platform. I guess we don't need to. We already did the spec work, so let's go to Handmade, Win32 Handmade, and implement the functions that we have not implemented yet, right? Because we basically spammed out these functions right here. Win32 get all files of type begin, Win32 get all files of type end, Win32 open file, Win32 read data from file, and Win32 file error, right? So those were our functions that were the platform layer was using. I'm sorry, that the platform non-specific code was using to call down to get file stuff when it needed it. And so what we want to do here is we want to actually implement these so that we can actually do exactly what these files are supposed to do. We'll do a very simple version of it first, and then we'll make a slightly better one in terms of implementing it in its completeness. I'll show you kind of what I'm thinking of there. All right, so we already know how to do this stuff because we already wrote it all, right? We just wrote it in a different way. So here you see we have debug platform read entire file. So really, all I really wanted to do was have, debug platform read entire file was really mostly what we actually wanted to have happen, right? So when we call Win32 open file, right, really all I'm going to do is split these into two pieces. So we've got the one here where I'm going to go ahead and read the file, like this one, for example, right? We've got this. We've got the read file stuff happening. There we go. And we've got sort of this Win32 open file stuff happening. So what I want to do now is I just want to go ahead and make Win32 open file do just the file open part of things. And then also, of course, I got the close handle here, which I can go ahead and put in. Oh, you know what? We never close our file handles. Like, we just don't. Because we keep them open forever. So I feel like we actually don't need close handle. I could do a thing here, just a note, right, that we have a close handle here in case we want to do it at some point. In case we want something that close, like, I don't think, like some kind of update in place sort of thing, but anyway, so we have like open file, right? We just have Win32 close file or something like that, and it would be something like this. But for now, we don't actually want to do that because we never close our files, right? Okay, so in Win32 open file, we go ahead and do a create file on some file that we're trying to open. We check to see whether we've loaded it, and we get the file size. Now I want to go ahead and look at Handmade platform and just see what it is that I'm actually supposed to do. I return a platform file handle. I guess, and I guess we never need to even know the size. So really this get file size ex thing is really not relevant. We really don't need that. And so really the entirety of what we're doing is just this file handle thing, right? So I'm just going to define a struct here, which is the platform file handle struct for Win32. And so what I'm going to do there is I'm going to put in the handle, right? This is the Win32 handle for our handle. Basically it's the kernel handle for our handle. We have kind of like a 2 layers of handle essentially. And then we also have an error code, right? Like had error, something like that, right? And the reason that we have to do this, right? Oh, I guess I already kind of spec'd this out, so I don't have to do that. So here's platform file handle. Here's that struct, right? So what I can do is just put that in here. So we know that we have like the regular. This is sort of the generic part, right? If you will. We'll just, I don't know what we want to do. Call that H. And then we have the Win32 handle down here, right? So we already have the has error stuff spoken for, basically. So all I have to do here is I go, okay, I've got the result. The result is going to be a platform file handle, right? And we'll just assume that it's, nothing, and that we're going to return it, right? And I suppose, another thing I could choose to do is I could change the meaning of has errors. I could make the meaning of has errors actually be that it doesn't have errors. So it's initialized to 0, meaning that we don't know if it's right yet, and then we set it to true when we load it. And I kind of like that. So I think I might say that it's actually no errors. I like that a little bit better. Yeah, I kind of like that a little bit better. So what we do here is we assume that we have an error, which is that we couldn't load the file, right? And then if we actually can, then that is when we would set the result no errors, right? So we could do result, Win32 handle. We could do it like this, right? And we could set, I guess we could set it like this. Something like that. And that makes this kind of really nice, very, very simple function, right? Nothing particularly confusing going on there. Very, very clean, very simple, right? And these guys would all operate on one of these things, like so. And when we return the result, we wouldn't return this whole result, obviously. I guess this is actually, well, you know what? This would actually have to be an allocation, right? Because we need to return a pointer to that thing. So we actually do need to allocate this, basically from our Win32 heap or whatever, right? So this is actually something like a heap alloc, right? Where we're just going to grab some memory that's Win32 specific. And it's not memory that we're ever going to give back, if that makes sense. It's memory that we're never going to give back. Because we never closed the file handle. If we did, we would get rid of it. We could also use virtualalloc instead, since that way we keep it to just using virtualalloc. Normally, you probably wouldn't use virtualalloc for something so tiny. But again, just to keep it to, since we didn't bother writing any kind of generic stuff in here, there's really no reason why we couldn't do it that way. It's totally fine to do it this way, right? But the reason for that is it's going to take up a ton of memory just for this simple file handle. And so that's not something you would normally do if you were actually going to be doing anything fancy here, right? So, and I can put it to do there as well, which is that if we want someday make an actual arena used by Win32 to subdivide out that space. But again, don't really care about that. It's not really relevant. It's never going to affect anything because the number of file handles is going to be pretty small, right? On the order of 10 would be a large number of asset files for us to process. So that doesn't seem particularly interesting either way, right? So that's fine. And we can go ahead and do our Win32 handle stuff then at that point, assuming that the result actually worked out, right? And then, of course, we can cast this because it is a platform file handle, because that's what it begins with, right? So that looks all pretty reasonable to me. We've got the allocation. And like I said, we were about 12 minutes over, I think, when we started. So we want to go to 6:12. That would be an hour. So that's all good. I think that's fine for reading into that file handle there. I like that. We then do read data from file. Read data from file is going to assume that it got one of these, right? So it's, again, I'm going to go ahead and look at the platform here to see what exactly this what it takes as its parameters. So when we do platform read data from file, we have a source here, right? So I'm going to go ahead and do handle equals source, like so. And then we've got the offset and the size and so on, right? So what we got to do here we've got 2 steps, like I said, we've got to do. We don't need to allocate any memory or anything. We're just going to read like this. And when we do the read file, we're going to do the file size, right? So we're going to do the size. And then we're going to do the offset. We have to do as a seek, right? Like we actually have to do a seek to get that. Because right now, read file works exactly the same way. Again, horrible API is when you, it's really a bad API when you have a location in a file that you have to use. Remember, I talked about this with fread and that sort of stuff. So what we want to do is we want to do a read that has an offset and a size. So really, read file is not quite what we want, or rather, this method of calling read file is not exactly what we want. What we want to use is actually the overlapped IO parameter. So let's go back here, and we didn't talk about this when we originally did it because we didn't use it. But if you take a look, read file has this thing called LP overlapped, right? And the LP overlap structure is a structure you can optionally pass in. And you can actually use this to specify more stuff, right? And what's interesting about it is if you look at the overlapped struct, what it actually has in it is it has the offset from which you would like to read the data, okay? And so even though read file in its normal incantation does not let you specify where you wanted to read the data from, if you actually use the overlapped portion of it, which is normally used to kick off background reads, right? If you actually use this portion of the Win32 API where you pass the overlap struct, you can get the correct API for file reading out of it. So again, yeah, it may look at first blush like the kernel, Windows kernel didn't implement the right file read API, but they actually secretly did. You just have to know about this overlapped guy at the end here, right? So what we actually want to do is we actually want to use one of these overlap structs. We want to set the overlap struct to what we need. So we'll go ahead and say overlapped, struct here, clear it to 0, and then we want to set our offset and our offset high, right? So we want to set overlapped offset and overlapped offset high, like so. And so those are going to be this offset that we have here. Remember, this is a 64-bit value. So what we want to do here, is we want to basically take this thing and mask off part of it, right? We want to say, okay, the low part of it is just going to be, the value masked off. The high part of it is just the value shifted down by 32 and then masked off, right? And that's how we would get that. And then so if we take a look here at what's going to happen, you can see it says, okay, we've got a pointer overlap. A pointer to an overlap structure is required if it was with file flag overlapped. We are not actually doing that, so we don't actually care about that. If the H file is open with file flag overlap, it point to a valid unique overlap, blah, blah, blah. We don't care about that because, again, we're not using it for background stuff just yet. For an H file that supports byte offsets, if you use this parameter, you must specify a byte offset at which to start reading from the file or device. You also specify the offset and offset high, which is what we set. And for an H file that doesn't, it doesn't matter, but obviously this H file does. That would be if you opened like a stream or something. But assuming you open a file on disk, it obviously has the ability to seek around, so that's fine. And that's all we really need to set. So basically we can go here and do H file, L buffer, right? We can set all this stuff exactly the way we used to, except now we can set that offset and offset high. So we don't have to worry about seeking, which is what we would really like to avoid, because we want this to be multi-thread safe. We don't want to have to issue seek commands that might seek somewhere and then have some other thread try to seek somewhere else and read at the same time, which would be a disaster, right? So that's all good. We've got the destination where we want to put it. So the only sticking point is the fact that Windows cannot do reads bigger than 4 gigabytes. Don't ask me why. I just know that they can't. And so there's actually, just this thing where we will probably have to do this same operation that we were doing, where we safe truncate down first and say, okay, we're going to assume that we'll never actually get something that's going to be too big for us, because chances are no individual asset in the asset file should ever be that large. But, we'll leave the possibility open that someday there would be, and then we just have to upgrade this Win32 platform layer to handle it, right? So we're going to do a safe truncate there so that we know that, we'll get an assert if we ever try to push that boundary in some bad way. And then we will go ahead and keep the rest of it, as is, basically. So this right here, file read succeeded, right? And this right here means that we've got an error, right? And so this is going to be something where we set the error in the actual where does it go? It's Win32 file. It's this guy right here, right? This is where we're actually going to call ourselves and just say there is a file error. The file error was on this handle, and it was that read file failed, right? So that's what happened. Win32 file error is really not doing anything at the moment. It's really just saying that that no errors function, right? You can see again in platform here. The only thing that was supposed to do when we did file error is it's supposed to take the handle and what the message was. So really all we're doing is we're ignoring the message for now, although we could do an output debug string, right, of the message if we wanted to, something like this. If handmade internal, we could output that. Something like this. Right? If we happen to be an internal build, we could spew that to the debug port. Later on, we have more debug information. Maybe we'll do something a little fancier there. I don't know. But what we do know is that no errors is going to become false. There will now be errors as soon as you call this function even once there's an error on the stream, right? So that's over. Now what we also could do here, again, is say no errors. We could say platform file no errors on the source. And we could just avoid ever trying to do any reads as well. If we know that if we've already gotten into a failure state, basically, we would not try to do any more reads on that handle, because who knows what would happen, right? So we'll just ignore any requests to read on a bad handle, if that makes sense. All right, so I think that's mostly it. Let's take a look. We got to figure out where we get the file name from, right? But I'm going to hard code that for now. Let's see. No errors is not a member. You are correct about that. I don't actually remember what the value was there. What is the name of that value? H. Don't ask me why I called it H. I don't know. So file name we don't have. Win32 handle we do have. Just put in the wrong thing there. File handle for this, we do have that. That's just the handle, Win32 handle, like so. And that cannot convert a parameter. That is true, because it would have to be H, right? All right. So the file name, what I'm going to do now is I'm just going to full on cheese that out. I'm just going to say that the file name, this stuff is all just going to be complete nonsense here, right? So what we're going to do is totally cheese this out so that we can test the loading. So what I'm going to do is I'm just going to say that when we have a file group, the file count is 1. To do Casey, actually implement this, right? And that's all we're going to do. And then when we come in here, we're just going to assume that we're always loading that same file, right? That we're loading our handmade data. We're going to load that test.hha, right? Does that make sense? Let's do Casey, actually implement this. Okay. And hey, I capitalize file name differently in 2 different cases. I do that all the time. And so now what we want to do is just kind of start stepping through it a little bit. I think we're pretty much done with the stream for today because we're about only a minute or 2 left. So what I want to do is just quickly step through this, but we're going to have to basically shut things down and leave them in a non-working state, because there's basically no chance that this stuff all worked correctly the first time, right? That's totally out of the question. So what we want to do is just kind of do a quick step through, and then we'll hold off on any real debugging until next time, right? Okay, so the file count is 1, which is what I said I wanted it to be. We're going to step through there. We'll grab out the first file, right? Well, actually, this is just getting the destination for the first file. That we got that tag base, which is set to 0. Remember, we got to rebase our tags, so that's we'll rebase the pointers into the tags. So the first thing we're going to do is we got to read out. Wait a minute. What? What is going on here? We haven't read the header yet. That's just banana cakes, right? Did you see that? Who wrote that? I don't know who wrote that, but whoever wrote that, whoever snuck in here and wrote that ridiculous code, you know, don't do that, right? I'm writing all this really good code, and then someone comes in and puts this ridiculousness in there. I don't know what's going on, right? Clearly some kind of gnome or imp in the machinery. So yeah, this is what reads the header. So obviously the asset type array size, that's cannot be computed here, right? That is something that can only be computed after the header actually gets read. And I don't know why anyone thought something other than that was going to happen. All right, try that one more time. So we come in here, we zero out the file header, we try to open the file, so there it is. Let's see if we were able to open the file. Looks like we were. Oh, sorry, that was just allocating the memory for it. We'll go ahead and create the file. And did we actually get one? We did. So our no errors should be set to 1, which is true, so that's good. We come through here, we attempt to read data from the file. We see whether we had any errors. We didn't. So we grab out our Win32 handle, right? We take a look at overlapped, and we set that to where we were trying to read from, which just in this case happens to just be 0 because we're reading the first thing. We're looking at the file size, which is 44. That should be 1 HHA headers worth of file, right? What is it? File header? Isn't there an HHA header? HHA header. So does somebody want to tell me why I can't take the size of that? What is the deal with that? All right, well, anyway, looks like we read it properly, so that's good. Oh, awesome. I know why that was. It's because we were in a different part of the code that didn't have HHA header compiled into it. And so the debugger felt that it was fine to just not tell us what that was. That's hilarious, right? Because remember, this is handmade.exe, and this is handmade temp.dll. And so it was using only the symbols from handmade.exe to look up what was in the watch window at that time. The people who make this product. You can tell if they do debugging, they're not very good at it, which I guess, you know, would be the joke anyway. Anyway, so point being, we're going to go ahead and get the asset type array size here, which is just however many there are, 204. Okay, that's fine. And I guess you know what, I should also look and see, this is the first time we're looking at us loading the header, right? So there's the magic value and stuff. There's the version number. There's the tag count. There's the asset type count, asset count. That all looks reasonable. You know, nothing too ridiculous there. So let's read. We're going to read in now the asset type array. We're going to make sure that the magic value and the version match. They do. We're going to go ahead and add the totals to our asset and tag counts. That's fine. Off we go. We're going to end there. We are going to push the arrays on. We're going to load our tags. Assuming that we load the tags in here, right? We're going to load into the tag array, however many there are, right? At the offset for the tag base, which we kind of did up here. Where is that tag base? File tag base is always a tag. Yeah, that looks right. It's set up there. So that's good. We come through here. We grab the asset count. We go through. Looks like we're just going to look through and however many types of assets there are, right? We go through every file for every asset type. We then look to see if we're still reading okay from this particular file. We go ahead and grab the asset type array for that particular asset type, right? We read it in, and looks like it didn't have any for that, which is correct because it's asset type 0. And that should just go apace, presumably. Yeah, that should just go till it reads all the assets of that type, which presumably would only happen once for any given file, and then it'll go through. All right, so that looks fine. But of course, we did not actually get the number of assets that we thought we would get. We loaded 50, and we expected 51. That's actually fine, because now that I think about it, the first asset is the null asset, and that asset would not actually be stored anywhere, if I'm not very much mistaken. Right? I think that's correct. So that's kind of interesting. So I don't know. We got to figure out what we want to do about that. I'm going to go ahead and kind of zip past this particular error for the moment. There's set next statement, and let's run. I don't think anything good's. Holy cow, dude. Well, it doesn't quite work correctly because I don't see any shadows. But that was pretty awesome. So now we're streaming out of the asset file. Wow, okay. So we've got a little bit of work to do. That is not quite correct yet. So we've got some work to do, but man, that was pretty good, right? All right. So we got to do that. I also wanted to put a to-do in here. To-do, KC, primacy numbers for asset files. But let's go ahead and go to the Q&A for now, because I think we've done enough programming for today. And yeah, that was kind of crazy that worked at all, given how much stuff we wrote. And we had only one really stupid thing in it, which was the fact that asset type array was getting computed above where it should have been, but that was pretty good. All right, so if you have questions, now is the time for the Q&A. Please ask questions, put a Q colon in front of them if you have questions about what we did on the stream that you just saw and you're confused about anything that you saw happen. Now would be a great time to ask that question. Put a Q colon in front of it, and I will answer it. Effector, stream's a bit behind. Okay, I will, yeah. What do you use when you need something more dynamic than arenas? Default to virtual alloc malloc, something completely different. The answer there is, well, first of all, you're actually probably going to see that in a second. Well, in a second. In you know, next week, probably, honestly. Because we do have one place in our code which needs something more dynamic, and that is the asset memory management. Because the assets themselves are dynamically sized, and so as we pull them in and out of memory, we will want to try and manage a block of memory coherently so that we can pull them in and out. Like I said, we have like a virtual memory system problem where we need to make that work, right? So you will see us do something like that. But really, what I would say is a general purpose allocator is totally fine to have in your program. This is probably the only place where we really need it, which is why you haven't seen me write one. But there's nothing wrong with a general purpose allocator. What you would typically do is you would say, how much memory do you want the general purpose allocator to use in general? You'd make a block for that, and then you'd just let it general purpose allocate out of there, right? And so if you literally just don't know what your memory allocation patterns are, that is what you would do. But 99% of the time, you know exactly what your memory allocation pattern is. And so what I try to kind of communicate to people is most of your stuff can operate on an arena, and should, because it's way, way faster than a general purpose allocator, right? And way cleaner, because you don't have to free individual things. You can just free the whole thing as a group. And that is actually probably the most valuable part of it, because it means you don't have to worry about memory leaks or any of this stuff. It's just all together and works, right? But if you actually have random access patterns going, or random allocation patterns going on, there's nothing wrong with the general purpose allocator. It's totally fine. Insofar as how handmade are you going to go on the Linux version? Probably not too handmade. And the reason for that is Linux is extremely temperamental in terms of its support for stuff. And so we will probably try to do the thing that most games do, which might be writing through SDL. It might be just writing through, it might be like looking at SDL, because I think that's what most games ship with, I don't know, and looking at which services they're using and try to use those same services. Because basically Linux is very, very bad at application compatibility. And so we need to try and do whatever it is that most people are doing, because I think that's the only chance we really have of running reliably. So I expect what we'll do is we'll like look at SDL, go, this is what most games are probably doing. How can we, let's write, let's write to those APIs, whatever they are, like ALSA or Pulse, or I don't know what they use for sound, and whatever, however they interface with X is how we'll try to interface with X. Quetzalcoatl, kind of off topic, but do you usually have that much luck not getting bugs? There's usually a bug. Well, there is a bug, right? The shadows didn't show up. And that's usually, I've been programming for long enough that the times when I actually have stuff that's just crazy buggy is actually pretty low. Because, I know how to avoid a lot of stuff, and in my head I'm tracking the right things, I guess, But everything's got some bugs, Like I said, there's no shadows in this one. There's probably another bug in there that just hasn't reared its head yet, right? There's like a hidden bug in there, And so, yeah, I mean, these days, like you've seen on the stream, a lot of times something works, not necessarily the first time, but very close to the first time. That is pretty typical. If you've been programming for a while, it's not typical if you haven't, right? If you're new to programming, that is not what will happen, because your brain isn't used to tracking all the stuff it needs to track. But even when you get to the point where I am, where you've been programming so old, you're old and crusty, you've been programming so long, you don't make a lot of those basic mistakes. You're still making mistakes. So I guarantee you that, there's mistakes in the code we just wrote, and we will have to find them. It's just, as you program more and more, you will just have a lot less of them every time you do something, right? They'll be a little more subtle. Only the subtle bugs will be there, only the non-obvious bugs will be there, or whatever, right? But that's just the nature of the game. And like I said, if you have a lot of problems getting stuff to work the first time and you're tearing your hair out, that's probably an experience thing that'll go away as you program more. But I don't know anyone who writes correct code the first time, no matter how, all the time, no matter how great they are. It doesn't happen. It doesn't happen for me. It doesn't happen for anyone I know. So it's like there's a limit to what you'll be able to do in that respect. But it's fine. You can usually get to a place where it's okay and you don't have too much, and there's not too much debugging to do. Do you usually define an API just by implementing it, or do you try to define the interface first? Plain flavored. Please tell me that you missed the past couple streams. Please tell me that you missed all the streams. In fact, I know you haven't, though, because I've seen you ask questions before. What do I always say? What do I always say? What do I always say? Write the usage code. You know what? That's not even big enough. Where's my pen? What day is today? Day 152. Write the usage code first. This is the thing that you should be doing. Always, 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 always write the usage code first. Like, the only time I can think of where maybe you wouldn't write the usage code first is if you literally have no idea how the thing you're calling works. You might need to experiment a bit to figure out what you're actually even trying to build down at the lower level. But even then, as soon as you know how it works, like as soon as you learned how the Win32 file APIs work at all, immediately back to the regular code and write the usage code first. Always write the usage code first. That's exactly what we did, right? You notice there was not a single piece of code in here, right? They were just stubs. And I had them all stubbed out. And I was like, this is exactly what's going to happen is these things are going to have to do what they say they do, right? Because I wrote the usage code first, and then I just went over and said, that's the API. And that is how you always, 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 always do it. You write the usage code first, that defines the API, and then you refine the API based on things that have to happen when you do the implementation. Like the implementation can then say, oh, I can't quite support what the best API would have been for some reason, performance, something, so I had to make a slight change, and then you backport that. But you always, 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 100% of the time, you never ever do anything other than write the usage code first, that defines the first pass API, and then you modify it only slightly from there based on your experience implementing it. That is what you must, absolutely must do. Canucles. Okay, now a real dumb question, super dumb, like nuking my non-existing reputation and locking it down at the level of atomic dust. What is usage code? Basically everything down the line that awaits to be fed data. Okay, so two things about that. First of all, that is not a dumb question. Second of all, don't worry about asking dumb questions because, for example, if Plain Favored had not asked that question, that was not a dumb question. It was a smart question. I was just disappointed because I wanted him to have heard on the previous stream me saying that, right? It is much better to ask that question so that we can re-go over it and drill it in, because this is really one of the most important things in programming. You can never really ask that question enough if you haven't internalized it yet. If you haven't internalized something about what I said, please ask those questions because you must internalize it. It is the most important thing. There are plenty of things we do on the stream that maybe you don't internalize or don't have to internalize, or it will take you a long time. This is the one you must internalize. It is so important. So I will explain what usage code is. All right. So in this case, what we had was we knew we had an asset file, and I wanted to read in the data from that asset file and use it. That's what I was trying to accomplish. I knew I needed a new API on the platform side for that because we had never defined a platform API for actually working with files that stay open, right? The only thing that we had in the platform layer was something that reads a whole file in memory at once. And that's exactly what we're not trying to do. We're trying to read little pieces out. So the question was, what new API should I put on the platform layer, right? What new API should I use there? So a couple questions. How did I know that was the API? How did I know that that side of the code was the API and not this side, right? Well, the reason is because which one will get reused, right? Which one is like a new little language that we're defining that people who want to do something will use again? No one's going to use this again, right? It's a piece of code that's entirely self-contained inside this allocate game assets thing, right? It's not an API. It's a whole list of things we're doing to put ourselves into a correct position. So we know this isn't an API, right? The API was this function, and we've already got it, right? So the other side is the thing that we might use multiple times. Anytime we need to read a file, we need this API to work, right? And so what we want to do is, since we know that it might be something that gets reused, right? We know that it's something that we might need to use multiple times in this, anytime our code needs to call to the platform layer to get file stuff, it's going to have to do this. What we want to do is make sure that it's set up to be as easy as possible for our code on the usage side to use it so that it slots in nicely and the API does what we want, and also so that the part of the code that gets written multiple times, which is the part that calls the API, will be as clean as possible, because there's only going to be one implementation of the API, but potentially multiple people who call it, right? And in fact, you can see that already. How many calls to read data from file are there already in just our asset loading system, right? Look at all those. So we want to make that call easy to do and do the correct thing. And we don't care how complicated this is because we only write it once. When you write something 5 times in one place and once somewhere else, right? It's the somewhere else that you want to be more complicated, because you want the most complicated stuff to be constructed and debugged once. Whereas if I were to push complexity or ugliness out of this somehow into here, I would have multiplied the complexity and the error proneness of that thing times 5. Okay? And that is the crucial thing to understand about API design. You need to push the complexity and the error-prone things down into where they are written the fewest number of times. Okay. So that is how you define who's on which side of an API boundary. Who is the person who is doing something once, and who is the person who's doing it many times, right? That is what that is, right? It's the caller going to the callee, okay? So that's how we know the call should be going that direction. That's how we did that. And so what I say by writing the usage code is, okay, now what I want to do, a lot of people what they do, a lot of programmers what they do, is then they go, okay, I need an API for reading files. Okay, let's go make a thing for reading files, right? And they open up an H file and they're like, doodly-doo, file API. And they're like, I don't know, let's make something that reads a file. So we make a bool here, and I say, read file, and that's going to take like the file to read, right? And it's going to take the size of the file. Oh, and I need a seek. Things have a seek in file APIs, right, or whatever. And they write some API out, and then they go and they implement it, right? Worse still, they might implement it and then test it. So they spent a tremendous amount of time developing this thing, right? At least the amount of time that we actually needed to take, and then plus potentially much more. And they have no idea if it actually does what they want. They have no idea, because they have never actually written any code that actually uses it. They're just going on like some vague, cloudy notion in their head about what this API might do, because what are the capabilities that it could have, right? It's like, I don't know, it's a file API. What can files do? Let's just start making stuff that files do, right? Bad, bad, bad. What you actually want to do is you want to start on the other side of the API. Pretend you have no idea what the API is. You don't even know you have no idea. You get the entire notion of it out of your head. And then what you do is you just write the code you were trying to write at the time that you decided you needed this API. And you write exactly what you wanted it to do for you. And you can see that that was exactly what I did on stream, right? I went through here and I said, okay, here's what we're going to do. I'm going to start writing the code as if I'm writing the actual final asset loader. What do I want it to do? I want it to get all of the HHAs out of, that the game can run. So I just flat out said that, right? I just flat out said get all the files of the type, right? Because I don't need the API to expose how that's done. And that's crucial, right? We could have started fiddling all sorts of stuff in here with like, okay, open a directory, like give me a path to a directory and iterate the files in the directory. That would have been awful, because then we're exporting all of these notions of what a directory is, how to iterate over them. What happens then when we want to iterate over HHA files that are in two locations, like the person's memory card and their console hard drive or something, right? Now all of a sudden that has to be bubbled up into the app, and the app has to know how to do that for all the possible platforms, and oh, it's a cloud state. Like there's all this stuff that happens there. We don't want that, right? So what instead I'm doing is I'm saying, what do I actually want? What do I actually need the platform layer to tell me? I just need it to tell me what are all the HHH files I could open. That's all I need, right? So give me those back. And then I said, okay, for each one of those, I need you to give me the header, right? How am I going to get that? Well, I need to read data from it, right? And I also going to need the asset type array. So I was like, okay, that's the same thing, right? I don't need two different calls for that. I can tell they're the same call, because I'm just like, well, I'm just reading data from the file. Here's where I want to read it. Here's how much I want to read. Put it here, right? So I defined that. And then, of course, yeah, I needed a way to open the file. So I said, hey, give me a handle of the file, because I need a way to reference this, right? I need a way to go from the list of files to a specific file. So that's what I typed, right? Then at the end, I was like, well, okay, I need some way to tell you I'm done, right? I'm done with this iteration. And really, I could have not written that, and then later we could have ping-ponged back when the API on the other side says, oh, I kind of need to know when I'm done, and then I would have added it in. We could have done that, but I just kind of knew from intuition. I was like, well, I should probably announce when I'm done, so that, because there's going to be some resource management probably on the other side, and it probably would like to know, right? So that was just a courtesy call, really. But we could have left that out, and then we would have implemented the Win32 thing, saw that we needed to know when it was done, and came back here. So you didn't need to know. You didn't need to have the experience that I've had and know, oh, I've implemented these sorts of things before, do it. You could have left that out, and you would have ping-ponged back here and gone, okay, now I'll make a slight change to the way I wrote the code, just add in this one line, right? We come down here, everything else I needed was entirely based off of stuff we already had, right? Oh, and the platform no file errors, that was perfect. I was like, oh, you know what? I don't want to check the error value on every file read because I don't care which ones of them failed. If any of them failed, the game's over, right? I can't keep operating on half a red file. That's not going to work, right? So then I know I don't want these things to reflect, like this is wrong. I don't want this to return a bool because I'm never going to look at that bool. What I want it to do is remember if it ever had a problem. And if it had the problem, then I'm just going to stop, right? I'm just going to say, okay, that file's done. We're never touching it again. Don't look at it. Don't breathe on it. Don't, do anything. Don't try to coax it back to life. It's done, right? Report an error to the user and say, bro, your files are messed, right? You got problems. I did the little, who has two thumbs and a corrupt file system? This guy. I guess I did guns. Guns are not the same as the air. Well, okay. Sorry, I'm not a very good bro. I don't even like football, right? Like, that doesn't work. So anyway, point being, that's what we did, and that is the example of writing the usage code first. It means write the thing that you were trying to do, write it as if you had the API that makes the most sense for that code. Get that code into a nice, well-reading, like it looks nice and clean, it does all the things you want it to do, it does them in the way you want them done, and then at that moment, when you're like, that looks good, that's what I'm happy with, I could ship this, I believe this would be good, that is when you then cut and paste these API calls into a new file, and that defines the API right there. And that's, again, exactly what we did on the stream. It was a little more complicated than it normally is because I had to make it go through the platform layer. So normally we would just cut and paste them directly into a C file and just implement them right there, right? So it's a little quicker that way normally. So we had to give that little layer of like how to route them through because it's platform specific, but that was it, right? So hopefully that answers the question. And again, do not feel self-conscious about asking questions about that. It is absolutely the most important thing. There is no question about that is not worth asking if you don't understand, because you have to understand that to be a good programmer. And there's so many programmers who don't understand it. So many. Most, I would say. Most people who make their living as a programmer do not understand that, and it is like the #1 cause of bad code. The #1 cause. There are plenty of causes, but that is the one that you absolutely must get right. And it is so prevalent that it is not done correctly that really, honestly, it is like #1 headspace thing, for sure. Do you feel that a lot of the common programs today have bloated code and or that coders need to learn to simplify bare bone their code? I don't know if I'd say bare bones, but yes, not like most of the code that's written today is massively bloated. Gasto5, doesn't anticipating the usage of the API require decades of work? I don't know that I'd say that. Obviously, you get better at it over time, but not really, because you can talk it out, right? Like here's an example. Let's talk out an example of something like if you didn't know it, right? So if you didn't know anything about the game asset file at all, right? And I just asked you to describe to me in English what was going on, right? You would have said something like what I wrote for the API, right? You would have said, well, okay, first I need to know what all the, files are that I'm going to load, right? You would have said like, okay, then I need to load the headers of each file because I need to know what's in them, right? So I got to load that, right? Then I need to allocate space to store everything, right? Then I need to load in the tags, right? We have the tags. Then I need to load in the assets, right? And when you look at what you type out, when you just think it through, like what are the stuff I have to do, it maps like really close, right? I'm like, okay, first I need to know what files I'm going to load. We did that, right? Then I need to go through them and load the headers, which is what we did, right? And as I'm typing this, I have all the things that I needed except for these parts, right? So it's not hard to figure out what part is the API. It doesn't take decades of experience for that because it's just as soon as you couldn't do something. Like as soon as I say first I need to know what files I'm going to load, I'm like, well, wait, we don't have any way to get that. We have no way to get that, right? That's the first API call, right? So there it is. I was just like, I don't have any way to get that. I made it up, right? That's when like Snuffleupagus comes over and it's like your imaginary friend is there and he's whatever you want him to be, right? It's like, I don't know how to write any code that does this with what we currently have because I don't have those services, so I just made it up, right? Snuffleupagus gets the files. We then start writing. I know how to do the rest of this stuff, right? I'm like, okay, I'm assuming that I got back the set of files. I don't know what they look like. I don't care. So I'm just going to say I got an array. I'll loop over it. Because we can always change this and we don't care, right? It could be anything. If the platform layer, in fact, when we go and implement this, we may change the implementation of that. It doesn't matter. The important part is just this loop that I can loop over them somehow. So I just wrote the simplest possible thing, and there we go. When I go through here, I'm like, okay, I've got to open the file. Like I've got to actually have a way to talk about the file. So I need a way to translate the index of the file that I'm, when I'm looping over these. I have to translate the index, right, into an actual thing I can make requests of. And so again, I don't have any way to do that. So Snuffleupagus comes and gives it to me. So I just said platform open file. All right, there we go. It's going to, I don't know what's going to do. I still don't know what it's going to be. I haven't implemented it, right? I have no idea how Snuffleupagus gets the file. He just gets it. He pulls it out of his snout. I don't care. The point is, I know that I've got a file group and it has some number of files in it. So I'm just going to say, I need file 5. Get it for me, right? Same thing here. I'm like, I want to read the header. How do I read the header? I don't know. We don't have any way to read the header. Snuffleupagus, read the header. That's what this call was, right? We could have called it read the header. And then later, when I typed in read the asset array, I would have been like, oh, hey, these are the same call, right? They're both just something that takes an offset, a size, and a thing, because that's what I was, and again, you don't need to necessarily know anything about a file API to do that. You just have to know, I need to get this data out of the file. I need to get the data from this offset, this much of it. I need to put it here. That's all you need to know. That's all I wrote, right? Just exactly that, just straight ahead. Didn't think anything about it, because anything that I would think about it is just going to complicate it. What I want to do is tell Snuffleupagus exactly what I wanted. I don't want to think about what Snuffleupagus is going to have to do. I just want to think about what I wanted Snuffleupagus to do. I say, Snuffleupagus, get me the file, that's the end of the thinking, right? Snuffleupagus, read this part of the file. That's the end of the thinking. And then later, on the second pass through, right, we can always fine-tune those to reflect the needs of Snuffleupagus. Certainly. I don't want to think I'm neglecting Snuffleupagus. But the first pass on the write the usage code, we don't think about Snuffleupagus. He's just going to show up and do what we want, right? And so, again, that's the crucial part of it. And if you weren't, if you don't have very much experience, maybe you type in something here that's like impossible to fulfill. You're just like, you say something that can't happen. When you go to do the implementation, you'll find that out. And then that's a fine time to just refine it. So you don't have to be 100% right, right? And so that's the thing that I want to, it's a very mental, very English, process, a logistical, simple thinking process that's kind of like what you would do in the real world. I want to do this, I want to do this, I want to do this. And every time you say that I want to do something and you don't have a way to do it, that's a new API, right? And that's the usage code. Canuckle says, so basically, when you're about to make shoes for a monster, you don't assume how many legs or toes it has. You just let it stomp around and then use the footprints to make the shoes. That's pretty much exactly right. James Widman, suggestion, call this Snuffy-oriented programming. Snuffleupagus-oriented programming, I would be totally psyched if for some reason write the usage code first became called Snuffleupagus-oriented programming. I would be more than happy to I don't know how you spell that. Snuffleupagus. So let's just say so it's SOP, right? this code was written using Snuffleupagus-oriented programming. Something like that. All right. All right, we are over time because, well, frankly, the question that someone thought was stupid, none of those questions were stupid. They were actually very good. And I'm very happy they were asked because I feel like every so often it's very good to restate this because, again, we talk about a lot of stuff on Handmade Hero. There's a lot to learn, and it doesn't help learning to say something once and then just let it sit forever and assume that people just magically pick up all the important stuff. That's not how learning works, right? Learning works by seeing something multiple times. And so it's always good to reinforce these things and go, hey, you know what? We talked about writing the usage code. Let's talk about it again. Because if there's one thing we can never talk about too much, it's that, right? And so I think that was very good. I'm glad we re-went over that. Hopefully, if you had some kind of confusion in your mind about how this stuff worked, hopefully we've gotten a little closer now to you going like, okay, I get it. Like that's how I can do this this process. And you know, the more you do it, the better you'll get at it, and the more you'll see how helpful it really is. I use it every day, even in code that I've written before. I always do it this way because everything is a little bit different, and there's always room for improvement and everything. And so I always like to kind of revisit that usage code and go, okay, what can I do here? What's this problem trying to say? Like, how do I want this to work? Let me refine the APIs even further. I constantly revisit that and always think about the usage code. So I always write it first, and I always keep it in mind later as I'm doing stuff. How can I make the usage code better? Because again, every time usage code happens many times, API code happens once. So if you can make improvements there, you're saving yourself a lot of problem and frustration and bugs and everything. You know, if you can push the complexity into the single use code rather than the multi-use code. All right. So that said, let's go ahead and wrap up for today. Let's see here. Close this down. Our Snuffleupagus oriented. Look at that. That was a little cute. A little Snuffleupagus. A little image from my childhood there. I'm so old that Snuffleupagus was still completely imaginary. Like he wasn't. No one had seen him but Big Bird. I feel like that's not true anymore. But yeah. So anyway. Okay, we'll go ahead and close Snuffleupagus and the read file function. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. You know, if you are someone who likes to play around with things, you like to experiment, and you would like to play around with the Handmade Hero source code, you can always get it. If you pre-order Handmade Hero on handmadehero.org, it comes with the source code. So you can go ahead and play around with it at home and learn from it, and it's a pretty handy way to do that. We also have a forum site where you can go to ask questions, and it also has annotated episode guides, stuff like that. I highly recommend checking it out. It's got ports to Mac and Linux by the community as well if you're trying to follow along on a different platform. We have a Patreon page if you want to just support the video series. It's always much appreciated. It's a place you can subscribe just to support the video series. And we also have a tweet bot that tweets the schedule at you. So if you would like to be aware of when we're going to be doing the live streams, you know, which days of that week and what hours and stuff, the tweet bot has got your back. So check that out. It's the right way to go. So thanks everyone for joining me. We will be back here again tomorrow, 5 p.m. Pacific Standard Time, Pacific Daylight Time, sorry. And I will also be speaking this Thursday at the Intel Buzz Workshop. So for any of you who are in Seattle who want to come by and say hi, that's going to be happening this Thursday as well. And so hopefully I'll see some people there that maybe watch the stream. So until tomorrow, I'll see you guys on the internet. Have fun programming, and have a good rest of your Monday. Take it easy, everyone.